Hello everybody, we're getting ready to do pre-algebra lesson 8.2 part 1 today. Part 2 and part 3 are over here. 8.2 linear equations and two variables. And we have a 32-point classwork sheet today and a 12-point note book-taking guide available at the email. Teachers, today's bell work is here. Give your students about, we got a writing thing here, and then as skydiver falls, does the atmospheric pressure increase or decrease? They're supposed to interpret this graph. Give your students 6 minutes on this. Okay, welcome back for our solutions here for today's bell work. As skydiver falls, atmospheric pressure increases. The reading on the skydiver's altimeter decreases. So here is your fall here on your skydiver, and then here's your altimeter reading. Or rather, this is your altitude in thousands of feet down here. Then this is atmospheric pressure here. So the skydiver lands. As the skydiver jumps, the jump has a lower atmospheric pressure and a higher altitude. So this is kind of a reverse, really, of what would happen sequentially. It's kind of confusing, actually. And then writing, describe the domain and range of the relation represented by the graph. So students, the explanation here of the range, this is your range here, and it shows that the landing point of the skydiver has a higher atmospheric pressure, and then where the skydiver jumps, it has a lower atmospheric pressure, and then the domain would be the altitude here, and it shows kind of like the inverse relationship here between thousands of feet in altitude and atmospheric pressure. So that's a long-winded explanation of that. Into our lesson. You solve the equations in one variable. You'll find solutions of equations in two variables. The Hawaiian volcano Mauna Loa in 1859 erupted. It traveled 32 miles to the Pacific Ocean at an average speed of per hour. Say, well, so what? Well, okay. An example of an equation. This is your classwork sheet, page 2. An example of an equation in two variables is 2x minus y equals 5. A solution of an equation x and y is an ordered pair. So it would be an ordered pair. It would be on a graph that you could plot your solution that produces a true statement when the values of x and y are substituted into the equation. In example 2, you see how to use the equation in two variables to describe the flow of lava toward the ocean, of course. Okay, students, in your own words, define equation in two variables and solution in your own words. Checking solutions. Tell whether the ordered pair is a solution of this equation here. So we have this ordered pair. How do we check that? Well, we plug it in. Here's our x and y. X and y is there. So we plug in those values and see if that equals 5. And it does. So this would be on the graph of the solution for this equation here. 1, negative 3 is the solution of 2x minus y equals 5. And see our next situation here, example 1, checking solutions again. So we have b, 4 and 7. This is our equation again. We plug in. Does it equal 5? When we plug in those values, 1 does not equal 5. For 4 and 7 is not a solution of 2x minus y equals 5. Okay, tell whether the ordered pair is a solution of this equation here. Here's our ordered pair. Students, This is your independent practice down here for this equation. Pay attention so you can solve yours. 1019 is a solution. When we plug that in to this equation here, 3 times 10 plus 2 times negative 19. Does that equal negative 8? It does. So this is on the graph for the solution of this equation up here. Okay, into example 2, finding solutions for the 1859 Mauna Loa eruption described above. The lava distance in miles from the ocean, T hours after it left the volcano, can be approximated by this equation here. Make a table of solutions for the equation. So substitute values of t into the equation here and then find the values of d. The table shows that the following ordered pairs are solutions of the equation. So at 0 hour is 32, 1 hour 28, 2 hours 24 miles from the ocean. So if that's the situation, here are again t and then d distance here. If we know that, then find the value of t when d equals 0. So when the distance is 0, t equals 8. So it takes 8 hours to get from the volcano to the ocean by putting in 0 here for 0 miles from the ocean. So 8 hours to reach the ocean. Okay, tell whether the ordered pair is a solution for the equation, -6, -7 here. Students, this is yours here, so pay attention so you can do yours up here and down here. X minus 2y equals 8. We plug in now. -6 minus 2 times -7. 8 equals 8. So -6 and -7 is a solution for this. And that was 8.2 part 1. Part 2, part 3 available here. Thank you very much.